Let's talk probability. Probability sometimes deals with rolling dice or die. So think about all the different possible outcomes on this particular die. You could get a 5, you could get a 6, a 3, a 1, a 2, a 4. So rolling a standard die, like this one, has 6 outcomes. And outcomes are just all of the possible results. It could be a 1 through 6, any one of those numbers. And then an event is a particular outcome or outcomes. And that's really what probability deals with, events and outcomes. So the probability of an event and I can show that using a capital P, so or capital P parentheses event is the number of favorable outcomes, favorable also meaning positive outcomes when it actually happens, over the total number of outcomes, over the total possible outcomes. Alright, so that's what probability is. Probability is basically part over whole, is how you can also think of it. So, or part over whole. That's just a simpler way to write it. So, let's use this same example. Let's say we were rolling this die, and we wanted to know the probability. So, find the probability, that's what capital P means, of getting a 1 or a 2. Well, I know probability is the number of favorable, so how many 1s and 2s are on this die? Well, I can't see them here, but I know that there's 1, 1 and 1, 2, so that's a total of 2 numbers. So 2 goes on top, that's my part. And then my whole is how many total outcomes were there? Well, we said there was 1 through 6, that's a total of 6 numbers. So it's 2 out of 6, and that reduces to, if I divide by 2, 1/3. So my probability of landing on a 1 or a 2 when I flip it gives me a 1/3 probability. Alright, what about the probability of getting an odd number? So I would say capital P parentheses odd. That means the probability of rolling an odd number. Well, how many odd numbers are there? Well, I have a 1, I have a 3, and I have a 5, so that's 3 of them. Out of how many total? Our whole still is 6. There's still 6 total possible outcomes. And then divide by 3, and that equals 1/2. And something else to consider, all probabilities range from 0 to 1. That's all, folks. That's right, just 0 to 1. So 0 represents impossible. No chance of happening. And 1 represents that it's certain that it's happening. For instance, if it's raining outside right now, I can say there's a 100% chance it's raining, or and 100 is the same thing as 1 whole, if we made it a decimal. So there's a 1 certainty that it's raining outside. And then if we're halfway in the middle, 1/2 means as likely as not. It can go either way. Right in the middle. And then the numbers on the right represent more likely. The further you get from 1/2, it's more likely that something will happen. And then the further you go to the left on this from 1/2, it's going to be less likely. And that's how probability works. So you can't have a negative probability, and you can't have a probability over 1. So all probabilities range from 0 to 1. All right, now flipping a coin has been around for a long time as a fair way to decide things, because it's as likely as not that it's going to be heads, or as likely as not that it's going to be tails. We even use the coin flip as a means to determine who's going to kick off in football. Whoa! Now let's say we wanted to look at the probability of heads, which I'll call as an H, and the probability of not heads, and again I can abbreviate with H rather than writing that all down. Capital H will work. Let's talk about what those two probabilities are. We said they're both as likely as not, so the probability of heads is really just 1/2, and the probability of not heads, in other words tails, would be 1/2. So those add up to 1 whole. And this is always true. It doesn't matter what the event is. So the probability of an event plus the probability of the opposite of that event is always 1. And the opposite of the event, that's also called the complement. No, not that complement. That complement's with an I. And we might need to work a little bit more for this type of complement. So finding the complement is basically you're just taking that probability and subtracting it from 1. So let's say we're looking at the weather forecast, and it says the chance of rain is 3/10, also known as 30%, and find the probability that it's not going to rain. Well, where we are, it seems to always be a 20 or 30% chance of rain, so this is pretty much commonplace. But all we do in the shortcut is we just subtract it from 1. So we do 1 minus the probability. So for instance here the probability is 3/10, so we would just do 1 minus 3/10, and 1 is the same thing as 10/10. So 10/10 minus 3/10 gives us 7/10. So that would be the probability that it's not going to rain. And that wraps up probability. The last thing we're going to talk about is odds. No, not odd numbers. You already know that. In fact, odds are actually closer to probability than what you may have been thinking. 1, 3, 5, 7, 9, 11, etc. So odds are just the number of favorable outcomes over the number of unfavorable. And we talk about odds a lot on the racetrack. The odds could be 3-1, 7-1, and so forth on whether or not the horse that you want is going to win the race. And obviously, money is betted on this event. But really, it all comes down to math. Alright, let's move on to pickleball. And we're going to find the odds of choosing a vowel from the letter tiles in the word pickleball. So imagine you had all these letter tiles spelling the word pickleball, and we just want to find the odds that it would be a vowel. So I'm going to do the number of favorable outcomes, or the number of vowels, and that would be I, E, and A. I have 3 letters that are vowels there. So 3 goes on top. That's my number of favorable outcomes. And the number of unfavorable would be all the letters that are not vowels. For instance, the P, the C, the K, the L, the B, the L, the L. So that should add up to 1, 2, 3, 4, 5, 6, 7. So 7 are not vowels. Or they would be consonants, right? So 3/7, or I can write it 3 to 7, as odds are typically written using a colon. And that would be the odds. Now the probability would have been 3 to 10. And I just want you to notice, for instance, these numbers, they add to the total. So if you knew the total amount, you could just subtract it. For instance, if we knew there were 10 letters and 3 vowels, we could do 10 minus 3 to come up with that 7. All right. I guess I'll see you on the pickleball court.